Good evening. My name is Ryan Wassel, and I would like to take a few minutes here today to talk about one of my interests and how it relates to chemistry. In the waning moments of Chemistry 1412, and throughout the semester for sure, I have wondered throughout most of the subjects we've talked about how this kind of all relates to me and my interest. The interest in particular that I'm talking about has to do with my career choice, which is to be a structural engineer, which in the end is a branch of civil engineering. So overall, this video is about how civil engineering and chemistry are correlated. In terms of an education standpoint, civil engineering requires a quote-unquote elementary level of understanding of chemistry, or at least a mastery of the things that you've learned in what would be called elementary chemistry. So this would more so do with the things that were taught in 1411, maybe more specialized things than what we were taught there. But the first subject that we've went over that comes to my mind anyway is solubility, particularly with concrete. You want to, a civil engineer works to create a safe place, safe infrastructure, and that requires to know whether or not the structure is stable, and that has in part chemistry, elements of chemistry rather, although it has more to do with physics and just raw mathematics. And that is kind of a theme with how chemistry relates to civil engineering. There are, of course, specific branches of civil engineering that require, that focus more so on chemistry. However, in terms of structural engineering, it's more so lots of physics and mathematics knowledge with just a little bit of chemistry foundation. So in terms of more specific things in civil engineering that require this elementary knowledge or this mastery of elementary elements of chemistry, I just did a brief search online, and here are the things that kind of came up. So chemistry is involved in the mechanics of materials, so like how they work, how they hold up, which ones are going to be more appropriate for a given setting. For instance, certain metals tend to corrode near the sea, so you might use different materials. So the mechanics, how they work and how they hold up of materials, construction materials, concrete structure and design, that has a little bit to do with the solubility aspect of it, whether or not it'll be stable. Again, mostly physics and mathematics, but still some chemistry. Foundation strength, like the chemical makeup of the soil, whether or not it's sturdy enough. Concrete, again, that's the biggest involvement of chemistry in, for sure, civil engineering, but also other forms as well, is its relation to to concrete. I think, at least in what I found, the biggest way chemistry plays into civil engineering is the production of a new material, so one that is more sturdy or more flexible, or just more suited to a given environment. Again, things like corrosion and rust play a pretty big role in terms of how chemistry is involved in civil engineering. You know, you want to use materials that are not going to rust over, or corrode over, rather. Again, this is particularly the case by the sea, because you have that salt, and that the salt in the air and the water tends to cause the chemical reaction known as corrosion, and that'll break down the structure, making it a less safe environment. Civil engineering, of course, focuses on the inorganic side of chemistry. Lately, we've been focusing on organic chemistry and just the structures of that. But thankfully, I will not have to deal with that or naming thereof. It's just focused on inorganic chemistry. Like I said before, chemistry plays a more minor role in civil engineering than physics and raw math, but again, still required. Employers will want to look for someone who has as I've been saying, a mastery of elementary knowledge of chemistry. And in a thread that civil engineers were discussing, like, about their college experience and how they ended up using chemistry, the biggest thing that they said they wish to pay more attention to is metallurgy rather. I don't know if I'm pronouncing that right, but it's basically the study of metals and their production and purification. So similar to what we've been looking at with the electric cells, or the one where you just produce raw metals with electrodes. So it's similar to that, processes of purifying metal and the production of their alloys, because alloys are more commonly used rather in construction than just raw metal. Of course, civil engineers need to make a safe environment, and that involves monitoring chemical safety. So like chemical hazards need to be looked at, and that's more of an indirect way that more of a direct way, indirect, that chemistry involves civil engineering, just looking over the whole area and determining whether an area is safe, chemical exposure, that kind of thing. Preventing rust, again, you want to select certain alloys, certain metals that aren't susceptible to rust and will then break down and become unsafe to be around. All in all, this is just like principal foundation. So the more detailed areas of especially chemistry 1412 and chem 1411 aren't going to be used in in civil engineering. It's more so to do with the structure, the stability of an inorganic compound, and again, that is primarily with concrete. I did learn that 2 semesters at least are going to be required if I do plan on pursuing civil engineering. So my time in chemistry 1412 with all of you has been well spent, and I hope to take these principles that I've learned into university and build on them from there in a more engineering-oriented class. One class that I found that is particularly tied with engineering is advanced chemistry, and it's the studies of like sturdiness and concrete and that kind of thing. The principles of chemistry that you will find in more practical applications. Although I must admit that the essay I read was a criticism over the class, kind of, a recommendation for what should be done moving forward. All in all, civil engineering does not require a lot of chemistry, or at least a lot of very focused chemistry. Just very basic calculations, kind of formulaic calculations, that kind of thing. So I think I have a good basis for continuing on in civil engineering in terms of chemistry. I do need to go over physics, and that I will plan on taking next year, but my chemistry portion has been filled. And actually, after a brief overview of the physics course, or at least a physics course that is recommended or required, I haven't looked into the nitty-gritty details of it, but required for civil engineering, seems to kind of reflect at least the statement by the civil engineers in the thread that I read, that most of what you learn in school does not really apply in actuality in the field in terms of engineering. Engineering, at least from what I have heard, is a very self-driven process. Involves a lot of learning on your own, so that might lead me to unexpected pathways that kind of have some relation to chemistry, but as of now, I think I have explored most, if not all, avenues that chemistry is involved in civil engineering. So, after this brief wrap-up, of course, the biggest thing I've learned is very basic knowledge of chemistry is needed. So it's not as important a factor in at least structural engineering as physics or just raw mathematical skill, is, and I hope you at least learned a little bit from my brief presentation here today. Thank you.